the corresponding sides are proportional. So we normally use the symbol, this symbol, to represent, as to show it means similar. So whenever you see anything like this about a triangle, it means similar. So example, if someone say triangle ABC and writes this symbol, it may be DEF. This means similar. This means triangle ABC is similar to triangle that. So this symbol, that's what we use to denote similarity. So let's look at, we've done the first one. So let's look at similarity postulate and theorems. So the first one is AA similarity postulate. It says if two angles of one triangle are congruent to two angles of another triangle, and if the ratio of the corresponding sides are proportional, then the triangle are similar. So mind you, the ratio of the side must be proportional, but to know which of them, whether it's the postulate or the theorem, we now check if it's two angles. So if two angles of one triangle is the same as two angles of another triangle, that's first condition. Second one, if now the ratio of the corresponding sides are proportional, then they are similar. So as you can see, angle A here, angle A is the same as, if you check this triangle, is the same as angle F, while angle B is the same as angle D. So these two is enough. Common sense will tell us that once two angles are the same in two different triangles, the third one will also be the same. So that's the first one. We now, if the ratio of the corresponding side. So if you check A, angle A, the side opposite that is A. So A corresponds to, which one is opposite F here? Angle F, F. You see it? So if the ratio of the corresponding sides are, so which one do we use? B. So angle B here is opposite that, which is B, while angle D is opposite. So once these conditions are made, you know that this implies that triangle ABC is similar to triangle FDE, by which postulate? By AA similarity postulate. So that's what the postulate is saying. You know, once it's a postulate, we don't have any proof for that. It's a postulate, just common sense. So the second one is this SAS similarity theorem. So this one says if an angle of one triangle is congruent to an angle of another triangle, and if the ratio of the sides including this angle are proportional, then the triangles are similar. So I told you the ratio is always there, but to know whether it's a postulate or theorem, you now check here if the angle. So if you check let me use this and explain. SAS means angle. The angle is between the two given sides. If you check, so once they are the same, as you can see, they have the same angle. I will now check. So we see that angle C is equal to angle E. So that's this angle now, the common angle. And if you now check the sides, if the sides including the ratio is the same or proportional. So let's check. So we see that 5, if we do 5 over 25, let's check 3 over 15. Do you see it's correct? This is 1 over 5 and this is also 1 over 5. So do you see it? So it implies that therefore this is triangle ABC is similar to triangle is similar to triangle DFE, by which theory or postulate SAS similarity theorem. So that's it. So let's move to the third one, which is side SSS. Okay, the third one we have SSS similarity theorem. It says if corresponding sides of two triangles are proportional, then the triangles are similar. So here we're not talking about angle now. Once the sides are proportional, the ratio, if the ratio are equal or proportional, it means they are similar, even without knowing the angles. So let's check. If you check now here, this side, if I check DE of this one, because we have two triangles, this and this. If you check AC, let's check the ratio. Okay, or let's check 6, which is BE over BC. Let's check after we plug in values so that we know. And finally, if you do BD over BA, so let's check whether they are equal. So if you see D is 2 over 6, AC is 6, while BE is 6 over BC is 6 plus 12, which is 18, and finally BD is 10 and this one is 30. So what do you notice? They always give us the same. They are equal, 1 over 3. So even without knowing the angles now, therefore triangle BAC is similar to triangle BED, by which theorem or postulate? By SSS similarity theorem. So it's a theorem. So that's it. Why the final one? So right triangle similarity theorem, that's the last one. Said if an acute angle of one right triangle is congruent to an acute angle of another triangle, so if they have the same acute angle, and meanwhile they must be right triangles, and if the ratio, I told you this is always the case, so you check that one. We now check if the ratio of the corresponding sides are proportional, then they are similar. Okay, let's look at these two triangles. If you notice, they are right triangle, so that's the first thing, and the acute angles are the same. So angle E is the same as angle J in the other second triangle, and both of them are right triangles. So aside being right triangle, you check whether if they have common acute angle. So if they have them, okay. So finally, let's check if the ratio of the sides are proportional. So if you check, this one is opposite 4, so I have 4. What of which one is opposite this angle, the red one? We don't know, okay, but we can get it using Pythagorean theorem. So we can get it. We can see that this should be 8. Yes, by Pythagorean theorem, this is 8. So if I check 4, this one is opposite 4. Why this one is opposite? This one is 8. So that's it. So let's check the hypotenuse here for the small one. Okay, we started with this one. Remember, don't make mistake. I started with this one. So whatever that be in the numerator will always be the one for that same triangle. So we started with the first triangle, which is 4. So everything in the numerator must come from this triangle. So they didn't give us the hypotenuse, but we can get it because this is a right triangle. This is 5 by Pythagorean theorem. So having done that, we can see that this is now 5 over 10. So which is correct? Yes. So we've checked the acute angle and the ratio. Therefore, triangle DAE is similar to triangle IFJ. So always use the corresponding angle. D corresponds to I, A corresponds to, so by which theorem? By right triangle similarity theorem. So but look at this, assuming you are asked this question now, what do you have to say? It said, are the triangles similar? This is a tricky one. Are they similar? Yes or no? Let's check something. So it must fall within the four. So that is AA, SAS, that's AA similarity postulates, SAS similarity theorem, SSS similarity theorem, or right triangle similarity. So this is not a right triangle, so it's off. But if you look at this, it seems we are given sides, two sides, including an angle in both of them. So C side, C included angle. So, and if you check, this is 5, 15. If I do 15 over 30, we'll get 1 over 2. 5 over 10, 1 over 2. It seems they are similar, but don't make that mistake. The sides, the two sides, assuming all the three sides, the ratio are the same, you know that they are similar. That one is SSS. But here, this angle has 3 hashes, but this one, the included angle here is 1, and is also here. So what do you have to say? No. So don't make mistake. Though the sides, the ratio of the sides are proportional, but by which one? You can't say it's SSS because we are not given the 3 sides. So we can't assume because we don't know what will be there. So that should be the one that would have given us the best answer. But here they gave us the angle here that is not the same. So see, it's not the same. It's here. It's not included. It's not an included angle. Here is an included angle, but it's not here. So the answer is no. Incomplete. We can't determine. So which is the best is no. So don't make that mistake. Let's find the value of x times y, xy. Looking at this, I'm seeing this is parallel to this. So this angle is alternate to this. And this is the same as this vertical angle. So we have two similar triangles because we are seeing two angles, interior angles that are the same in the two triangles. Therefore, we are looking for x. We have that x corresponds to 4 and y corresponds to y. Yes, a similar triangle theorem. So which implies that xy is 36. So the answer is option B. Which of the following is equal to C over B? Okay. As you can see, if we call here, okay, let's call here theta. We see that by a triangle theorem, here is theta minus alpha. Yes, by a triangle theorem, if you sum the interior angles, remote interior gives you a stereo. So we now have these two triangles so that we'll compare. So this one is A, B, C is similar to the other one, which is A, D, and C. So A, B, C, this is x plus y, this is C, and this is B. Why this one is C? this is Y, and this is B. So the two triangles are similar, yes, because this angle here is alpha, while this is theta, yes. This, if you sum this, why this is theta and this is alpha. So once they have two angles that are the same, they are similar, you can now compare the ratio. So we see that C, because we're asking C over B, which of them is equal to C over B. So C here corresponds to C is opposite the one without sum, so Z. You see it. Y, because I'm bringing in B, C and B, YB here is opposite alpha. Which one is opposite alpha? Y. Yes. Therefore, if you do C over B, it's now Z over Y. So the answer is Z over Y. So it's a tricky one. It asks find the value of Qx. Qs is this. But the first thing we have to know that QR, this is 12, yes, by Pythagorean theorem. So since we have a right angle triangle, QR is equal to 12 cm by Pythagorean theorem. So let's call this is x, and since here is 90, if I call here theta, since here is theta, here is 90 minus theta, yes, to sum to 180, and also since here is 90, here should be theta, so that this angle on a straight line is 180. This is 90 minus theta. So these two triangles are similar now, yes. I'm saying that triangle PQR is similar to triangle RXT by right triangle similarity theorem. So we now compare. We are looking for x, so let's start with that. X corresponds to, x is opposite theta. Which one is opposite theta here? 5. So x over 5 equals to the other side, which is opposite 90 minus theta. This one is opposite 12. Yes. So this 1 over 6, therefore x is 1 over 6 is 5 over 6. So when we are not asked to find x, we are asked to find q. Therefore qs will now be 12 plus 5 over 6. Yes, that's the answer, which is 12 whole number 5 over 6 cm. So that's the answer. The area of triangle RQP is 150 if PQ equals PS and is equals 15. Find the value of XT. So we're looking for XT. Let's call it X. And you know, this is a similar triangle. Yes, because this is theta and 90. This is also theta and 90. So this triangle is similar to this. And they said PQ is 15. So from here to here is 15. Yes, CM. YPS Yes, so here is also 15 cm. That's from here to here. So let's call here y. So let's get, because they gave us area, so that area of triangle PRQP is 1/5. Yes, which implies that half area, this is a right angle triangle, half RPQ, half base, which is half times 15 times y is equal to 1/5. Yes. So what do you see? You see that y will be 20. Yes, it's 10. So y is 20. So with y being 20, we can get PR. Therefore, PR will be, by Pythagorean theory, will be square root of 15 squared plus 20 squared. That's if you sum the square of this and this, gives you PR. Yes, which is 25. Yes, by Pythagorean theorem. So we've noted that here. Let's put it so that we see that from here is 25 cm now. So since we've known this, we can now compare using similar triangle theorem. We are looking for x. So therefore, x over x is opposite theta. What is opposite with y? So y is 20 is equal to, okay, y, the hypotenuse here, is 15, is equal to the hypotenuse of the big one, which is 25. Yes, I write triangle similarity theory. Similarity theorem. So solving for x is now equal to 15 times 20 over 25, which is, this is, okay, let's just reduce. 5 here is 3, 5 here is 5, that is 3 times 4, so x is 12. So what we are looking for, ST is 12. So that's it. Nice one. So we're on triangle proportional segment theorem. It states that if a line parallel to any side of a triangle intersects the other two sides, then it divides the two sides proportionally. So I'm saying that if you have a triangle and you have a line parallel to one of the sides, so assuming the segment here is A, here is B, here is C, while this is D. So the theorem states that A over B is equal to C over D. So that's the statement. So to prove that, let's look at quick proof. So let's look at the quick proof. We'll see that this triangle A, okay, let's call here. So let's call A, B, C, D, E. So we see that triangle, okay, let me use, we see that triangle ADE is similar to triangle ABC. Yes. So which implies that, because as you can see, you are seeing the parallel line. Why are they similar? This angle corresponds to this. Why this corresponds to that? So we see that A, that's this big one, the length, this big length, A plus B over A it will be equal to C plus D over C. Yes. And A over A is 1 plus B over A. Why this is 1 plus D over C. So 1 off, we have B over A equals D over C, which is the same as A over B equals C over D. So we've proved that. So let's solve this question. So as you can see, we are seeing this triangle, and this line is parallel to this, so we can use triangle proportional segment theory. We can still call it side splitter. So another name for this is side splitter theory. So that's another name. So we're looking for A. So if A over 8, since I'm looking for A over 8 will be equal to 2 over 3. So which implies that A is now 16 over 3. That's the answer. So it's very simple. Option C, X and Y. So as you can see, I'm seeing a line parallel to this side BC. So we have that 6 over X will be equal to Y over 4. Yes. Why? By triangle proportional segment theory. Therefore, if you cross multiply, I have 24. So the answer is 24 cm squared. Option C. So they're asked to find the value of X plus Y. Okay, as you can see, we have X and Y unknown. So first of all, we'll use the normal triangle theorem, that's similar triangle theorem. We know that this is parallel to this, so this corresponds to this, why this corresponds to that. So we see that triangle ADE is similar to triangle ABC, yes, which implies that if we do the big one, which is Y plus 2 over Y, should be Y over Y, that's the big one, corresponds to this one. So it will be equal to the big one, which is 24, corresponds to 16. Yes. And Y over Y is 1 plus 2 over Y. Why this is 8 here is 3, 8 here is 2. So this is 2 over Y, 3 over 2 minus Y is 1 over 2. So if you solve for Y is 4. So we've gotten Y as 4. We now use our triangle proportional segment theorem to get X. So therefore, Y over 2 is equal to X over 3Y plus 2. Why? Triangle proportional segment theory. So we know that Y is 4. So 4 over 2 is 2. Why this is X over this 3 times 4 is 12. 12 plus that is 14. Yes. So what do you see? See that x will be 2 times 14, which is 28. Therefore, x plus y we are asked to find is 28 plus 4. So our answer is 30. The answer is 32. In this section we'll talk about parallel proportional segment theorem. Parallel proportional segment theorem states that if 3 parallel lines intersect 2 transversals, then the transversals are divided proportionally. So can you see the 3 parallel lines and they intersect the transversal? So this and this is the transversal. So this is also the transversal. So BA and CD are the transversal. So we are saying that if you have anything of this form, that is A over B will be equal to C over D. That's what the theorem is stating. But to show you that it's correct, let me do a quick proof. Let's do a quick proof. So assuming I add an auxiliary line running from K to P, so let's add it. So I've added that. So let's call this segment X, Y this is Y. So maybe let's call here O P Q L M N O P Q R. So let's call here R. Okay, the points here. So we'll now apply, as you can see, this is like our triangle proportional segment theorem, because this line is parallel to this. So if you could remember, that if you have anything of this form, this is parallel to this side, and if you have here as A, here as B, C, D, that A over B is the same as C over D by the triangle proportional segment theorem. So using that here, we can easily see that looking at this triangle, okay, let's look at this triangle KMP and KLB. So applying that, we'll see that X over Y will be the same as A over B. Yes. Also, the same X over Y, I used X over Y for this triangle is A over B. And also that same, okay, let's see, X over Y will be C over D. Yes. Why is this so? By triangle proportional segment theorem. Yes, by this theorem. So by what? Triangle proportional segment theorem. Therefore, making it the subject of formula. Okay, equating this is X over Y, this is X over Y. Therefore, A over B is now C over D. So we've proved that. So let's look at this question. They said if NP equals 3NO, then A is dash. So let's call NO. Let's call it, length NO be X. So let's call here, let's call it X. And they now tell us that NP, they are saying that NP is now 3NO. So this is NP is 3 times, and so here should be 2x. For it to be 3x, now 3NO. So that's it. Therefore, A over 4, now using the parallel proportional segment theory, a over 4 is now x, therefore a is now, this is half, so 4 over 2, which is 2. A is 2 because this is half, so that is the answer, 2 cm, option B. So said if LM is 1/2 less than 3 times the length KL, then KL is what? Dash. So they said we have to find KL. So let's call KL X. KL is X. And they told us that LM is 1/2 less than 3 times KL. So this is, LM is now 3 times KL minus 1/2, that is 1 over 2. That's from the question. So let's finish up. Therefore, using our parallel proportional segment theorem, we'll see that x over 3x minus half is equal to 2 over 5. That's by parallel proportional segment theorem. So we'll cross multiply. This is 5x, y this is 6x minus 1. You see that 1 is now equal to x. X is equal to 1, and that's what we are asked to find. KL is x, so that's the answer, is 1, which is option A. So it's a tricky one. So final one on this parallel proportional segment, they say find the value of y over x. So we are asked find the value of y over x. So this is these angles here shows that these lines are parallel. Yes, this is parallel to that, for them to have the same angle, the same corresponding angles. So we can use our parallel proportional segment theory. 3 lines, you see it, you see it, 3 parallel lines intersecting 2 transversal. A, F and B, E are the transversal, so we can use that. So using the theorem, we know that y over 20 will be equal to x over half. Yes, by what? Parallel proportional segment theorem. So which implies that y is equal to 40. Yes, 1 over 2. So that's the answer. Y over x, y over x is now equal to 40. That's the answer. Y over x is 40, option D. In this section, we're going to talk about mid-segment theory. So mid-segment theory states that the segment whose endpoints are the midpoints of the 2 sides of a triangle is parallel to the third side and has a length equals half the length of the third side. So that's what we are saying, that if these 2 points are the middle of the sides of this triangle, then to be parallel to this third one and also has a length equals half of the length of this third one. So let's prove that. Assuming we have, here is x, so here must be x. If here is y, here must be y. So since I'm proving, so since if you check AD over DB will be the same as AE over EC. Yes, they are equal. That's x over x is the same thing as y over y. Implies that DE is parallel to BC. Yes, by what theorem? By triangle proportional segment theory. So also, if you have AD over, because this is now a similar triangle, so this angle corresponds to this angle. This one corresponds to this, while this corresponds to this. So we'll now apply our similar triangle theorem, normal similar triangle theorem. AD over AB must be equal to AE over EC. Yes, since AD over AB is equal to AE over AC, yes, because they will give us half, implies that that's the ratio of the size will be 1:2. So automatically DE implies that DE must be half of BC. Yes, since if you do the ratio of the sides, x over 2x is half, y over 2y is half, therefore this over this should be half. So that's how we've proved that. Therefore DE must be half of BC. So that's by similar triangle theorem. Now maybe side angle side similarity theorem. So we've proved that. So let's solve a question. I said if AE is equal to EG, which is 4, and AD is DF is equal to DF, which is 5, AC is equal to AB, which is 20, and DE is equal to 8, then BC is, so let's label. We start with the first one. It said AD DF, there are 5s, so this is 5 5, while AE EG 4 4. So what do you have to say? This is the middle, and this is the middle, which shows that this is parallel to this. Yes, we're going to use mid-segment theorem. So why this? They said AB is 20. So if here is 10, here is 10, for it to be 20. Why DE is 8. So here is DE is 8. We have to find BC. Wait. We have to find BC. Okay. This just shows that for this to be the middle of this, G is also the middle. So here should be, since here is 8, here is 8. Yes. So I'm saying that GC is equal to 8 by mid-segment theorem. Mid-segment theorem. Also, we are looking for BC. Since here is 8, FG will be 16 by that same, because I told whatever is there is half of that. Whatever is there is half of this. So this is 8, this should be 16. And BC now, since here is 16, therefore BC is equal to 32. Yes, by that same mid-segment. So it's a equation on that. Said find the area of triangle ABC if the area of triangle DEF is 30 cm square. So we're going to see that for this to be the middle, if here is x, here is x, here is y, here is y. Are you following? So if you join again, this shows that this is parallel to that, right? So if you look at the other one, this is the middle. So if I call here z, here is also z. So what do you have to say? Y, z, z. So this is now the middle. E and F are the middle. So this shows that this is parallel to this. Yes. So since here is 2x, here is x. The same way as here is 2z, here is z. And since here is 2y, here is y. So what do you have to say? You can see that the triangles are the same. Yes. So if you join all the midpoints, you form a triangle that have equal areas. Yes, because this is xyz, xyz, xyz. So the areas are the same. So with that, we can finish up the solution. Find the area of triangle ABC, if the area of triangle DEF. So since the equal, this one is 30, therefore the area of triangle ABC will now be 4 times 30, since they will have the same area. This ones have the, so this 30, so the answer is 120 cm squared. So option C. Nice question. So we're given this. So the next thing is to draw a diagram. So as long as these are the midpoints, the area of the triangle formed here are the same. So the 4 triangle had the same area. And since the area of this triangle, if you check, this is a right angle triangle, because 1.5 squared plus 2 squared must give us 2.5 squared. So it's a right angle triangle. Therefore, the area of the triangle we are looking for, which is DEF, will be 1 over 4 times the area of this one, which is 1 over 2 times 1.5 times 2. So our answer is 0.375. So that's it. Because this area of a right angle triangle, half times the product of the legs. So whereas D, E, and F are the midpoints of the sides of triangle ABC. If AB is that, AC is that, and BC is that, find the area of the triangle DEF. So DEF are the midpoints, and what you have to know that once you join the midpoints of the sides of a triangle, then the area of the triangle that is formed will be the area of the big triangle divided by 4. So see what I'm saying? So see what I'm saying? You have this triangle. So since these are the midpoints, we see that AC is 16. So if AC is 16, meaning that here is 8, A is 8, is 8, while BC is 26, meaning this is 13, AB is 30, which is 15. So by mid-segment theorem, we see that here is 26, here should be 13. Also by mid-segment theorem, this is 30, so EF will be 15. So the same thing from this 8. So what do you notice? We see that the area here, if here is area A, here is also A, here is also A, here is also A. So the areas of these 4 triangles are equal. So in case if you are asked to find the area given the area of the big one, so since we are not given, let's move straight. So we have 3 sides, and we know that area of a triangle given 3 sides is always square root x times x minus a times x minus b times x minus c. That's Heron's formula. That's area of a triangle given the 3 sides, where x is the semi-perimeter, that's perimeter over 2. So the sides are 8, 13 and 15 over 2. So we have, that's this 21, 36 over 2 is 18. Therefore, we can get the area now. Area of triangle DEF is now square root x is 18 times x minus 8, that's 18 minus 8 is 10 times 18 minus 13 is 5 and 18 minus 15 is 3. So, and we'll have a perfect square here. 18 is 9 times 2. Also 10 is 5 times 2. And this is 5 times 3. Okay. So what do you notice? Square root of 9 is 3. Square root of 25, because this is 25, is 5. Square root of 4, this is 4, is 2. So remaining only 3. So our answer is 30 root 3. So our answer is option B. So that's a very tricky question. Thank you. Okay. In this section, we're going to look at ratio of areas of similar triangle. Okay, let's get a formula. Let's do area of triangle ADE to that of area of triangle, the big one, which is triangle ABC. And we know from our basic formula, area of a triangle is half the base times height. So I have half base, which is half E, times the height of this small one is H1. Width of the big one, half times F times H2. Yes, and if you look at this, we can cancel out. We now left E over F times H1 over H2. But if you could remember, we know that H1 over H2, since as you can see this is parallel to this, will be equal to E over F, yes. Or it will be equal to, since this corresponds to this, that's why it's E over F, or could be A for the small one corresponds to B of the big one, or C of the small one corresponds to D. Yes, because they are similar, the two triangles are similar. Because so I'm saying that because triangle ADE is similar to triangle ABC, so that's why it's so. So what do you have to say? We now see that area of triangle ADE over that of triangle ABC will be equal to, so I can replace h1 over h2 as e over, so I have e squared over what? F squared. Or I can replace with a squared over b squared or c squared over d squared. So we've gotten a general formula that the ratio of areas of two similar triangles will be the same as the ratio of the squares of the corresponding sides. So I'm saying that therefore the ratio of areas of two similar triangles equals the ratio of the squares of the corresponding sides. So that's a formula. So let's use it and solve equation. They say find the ratio of area of triangle ABC to that of triangle ADE. Okay, we can see we can get it, because as you can see AE corresponds to AC since they are parallel. This side is parallel to this, shows that triangle AD is similar to triangle ABC. So I'm saying that therefore triangle area of triangle ABC to that of triangle AD is, so ABC is the big one, so the side is 4 plus 8, that's the big one, the longer side, this big triangle, the side is AC, corresponds to AE, which is over 4. 12 over 4 all squared. Yes, remember. Okay, let's write squared, and we know that we can write it as 4 plus 8 over 4 all squared. So our answer is 12 over 4. 12 over 4 is 3. 3 squared is 9. So 9 over 1. So our answer is option B. The ratio is 9:1. Okay, we are given equilateral triangle ABC is inscribed in equilateral triangle EFG such that the sides of triangle ABC are perpendicular to that of triangle EFG. Find the ratio of the area of triangle ABC to that of triangle okay, find the ratio of area of triangle ABC to that of triangle EFG. So first thing we have to do is to draw a diagram. So I've constructed a diagram before, so let's just copy and paste. Okay, so we have this diagram. Let's add some. So from the information given is the same as this, and the two are equilateral triangles, meaning interior angles are 60. The angles are 60. As each of them is 60 degrees. This is also 60. And since this is 90, because they told the one is perpendicular to the sides. So this should be 30. And if this is 30, this is 30, this is 30, yes, this is 90. Okay. And let's call the smallest side here x. So using our 30, 60, 90 triangle theorem, so this should be the hypotenuse here is 2x, while the side here is x times root 3. Remember, 30, 60, 90, the ratio of the side is 1 is to 1 is to root 3 is to 2. So if the one opposite 30 is x, the one opposite 60 will be that x times root 3, while the one opposite 90 is 2 times x. So that same logic, this is now x root 3, this is x root 3, making here to be x. This is x root 3, since an equilateral triangle, this is 2x, this is x. So what are we asked to find? The ratio of area of triangle ABC to that of, therefore the area of triangle ABC to that of triangle EFG. So what's ABC? ABC, remember, ratio of similar triangle. The two triangles are similar, is the ratio of the squares of the corresponding side. So the side here is x root 3 all squared over, while the side for EFG is 3x, as you can see, 3x, x plus 2x is 3x. So we can write this as, this is now 3x squared over 9x squared, which is 1 over 3. So the answer is 1 is to 3. So we can still generalize that for a triangle, if an equilateral triangle to be inscribed in another equilateral triangle, the side must be perpendicular and the ratio of the area will be 1 is to root 3. So that's it. Let's look at this, the next one. A square is inscribed in an isosceles triangle of area 9 cm square as shown. Find the area of triangle X SVQ. Okay, so they told us this is an isosceles triangle, and we know isosceles triangle, the two sides are congruent. And for it to be an isosceles triangle, remember this is 90, so it's also a right angle triangle. So making this angle to be the same as this, and since it's 90, here should be 45, while this is also 45. So this is also 45. This is also 45. Okay, and the sides, if we call, from what they said, a square is inscribed, so this is x. If we call, let me change in. If we call this side x, here is also x, here is also x, here is also x. And this is an isosceles triangle too, yes, because this is a square, so this interior angle will also be 90 since it's a square. This is 90, so this is also 90. So making this to be x also, the sides, it's also an isosceles right triangle, so this x, this x. So with that, we can finish the equation. So they say we should find the area of triangle. So we are going to use our ratio, the ratio of areas again. So we have area of triangle. So we are looking for SVQ. So let's compare it with SVQ with the bigger one, which is triangle. The bigger one is QPR. That's the bigger triangle. That's the one we are given, which is 9 cm. So using the formula we've learned, which is always the ratio of the squares of the corresponding sides. So we'll compare with the hypotenuse. We need to get the hypotenuse of this. So the hypotenuse here, this is x, this is x, this x times √2. Yes. So that's what we'll compare with. So we'll see that this is now x. Let me use white pen. X times √2 all squared. That's the hypotenuse of this one. While the hypotenuse of the big one is 3x. As you can see, x plus x plus x. And if you look at this, remember we are looking for this. Let's just write this is now 2x squared over 9x squared, which is 2 over 9. And if we compare, they gave us that therefore we are looking for triangle, the area of triangle SVQ. Why this one is 9? Yes, that's the big triangle. Is equal to 2 over 9. Yes. So what you have to say? Therefore, the area of SV triangle SVQ will be 2 cm squared. Yes. If you cancel out 9, and so we're left with 2 cm squared, which is option A. So we still use the knowledge of ratio of areas of similar triangle. We ask find the ratio of area of quadrilateral QRTU to that of PTS, triangle PTS. And as you can see, this is a parallelogram. As you can see, this parallel has 2 pairs of parallel sides, and that makes this angle. The two are equal by corresponding angle theorem. This also corresponds to that. And from here we see that here is the same as this. So if we call this x, this is also x. So what we now have to do, we now see that the ratio of area ratio of area of Q R T U to that of the big one, which is PTS. So we can write this quadrilateral in terms of the other two triangles, or in terms of the 3 triangles, which is the big one PTX minus the other 2 smaller ones, which are PRQ and QUS. So I used logic because I want to use the ratio of areas of triangles. So instead of writing this, I'll now do the big one minus this and this. And this divides, that is 1. We now have area of the ratio of P RQ over ratio of PTX minus ratio of QUS to that of P PTX. So what do you have to say? Since these two are okay, let's write 1 minus. So this small one, PR, this small triangle corresponds to the big one. So the ratio of the area is the same as the ratio of the squares of the corresponding sides, as x squared over 2x all squared. Also, this one is still similar to the big one, which is now the same, x over 2x all squared. Do you get the length of the big one is 2x, while the smaller ones are x? So what do you see? This is 1 minus, this is 1 over 4, 1 over 4. If you factor minus 1 over 4 plus 1 over 4 is 1 over 2. So the answer is half. Therefore, the ratio is 1:2. So it's a tricky one. So here they ask, what is the area of PQR? So before then, we can easily see that this is an isosceles triangle, and the height here is a perpendicular bisector. So it will bisect this into 2, which is √2 √2. So we now have a right angle triangle. So we can get this height using Pythagorean theorem. This is √3. As the square of this minus the square of this equals the square of that. So let's now use ratio of area of similar triangle. We are looking for PQR. So we have area of triangle PQR. PQR is the big one to that of the small one, which is PUS. So the ratio of area is the same as this ratio of the squares of the corresponding side, which is 6 squared over 2 √2 all squared. So we have 6 over 2 √2 all squared, which is 3 over √2 all squared, which is 9 over 2. We are looking for PQ triangle area of ratio of, we are looking for area of PQR, which is now 9 over 2 of area of PUS, and this is equal to half. This is half of half. The area of that is half base times height. So the base is 2 √2, the height is √3. So our answer will be this 2 √3. So I have 9 over 2 √6 cm squared. So that's the answer, which is option B. Tricky one. So this here they told us if PQ is 12, PR 13, what is area of PST? So let's write the ones we are given. We are given PQ to be 12. So here now, from here to here is 12. Running down here is 12. Why the hypotenuse is 13? Since this is 13, this is 12. Using Pythagorean theorem, this is now square root of 13 squared minus 12 squared. That gives us 5. So we now use our ratio of area. So we're looking for triangle, area of triangle PST. So if you use the area, ratio of area, PST is this small one. So to the big one, PRQ is now the ratio of the squares of the corresponding side. So 3 corresponds to 5 here because they are facing the same angle. So I have 3 squared over 5 squared, which is 9 over 25. Therefore, the area we are looking for, which is triangle PST, is 9 over 25 of area of triangle PRQ. And this is 9 over 25 times area of PRQ. The big triangle, which is half base times height. So the answer is now this 6, 5, so 54 over 5. That is 10 whole number 4 over 5 cm squared. So that should be option B. We'll move to the other one. So this is almost the same as the former one, but we're asked to find area of QRST. So we'll start by putting the values, the ones we are given. We are given this length to be 12, and we are given this hypotenuse to be 13. So using Pythagorean theorem, we'll see that this is 13 squared minus 12 squared, giving us 5. So using that same logic, ratio of area of similar triangle. So we are looking for this. We'll see that if we do, ratio of QRST to the big one, which is triangle PRQ, we can write QRST as the big one, which is the ratio of the big triangle, the area subtracts the smaller one, which is triangle PTS. Over the big one, which is triangle PRQ. Yes, and this divides this is 1 minus area of triangle PTX over area of triangle PRQ. So we're looking for area. Okay, let's just write QRST over that's triangle PRQ. So this is 1 minus, what's PT? The ratio of area is the same as of similar triangle. Ratio of areas of similar triangle. What's the ratio of this the squares of the corresponding sides? So for PAD is 3 squared over 5 squared. Yes, which is 1 minus 9 over 25, which is 16 over 25. So we are looking for, therefore we are looking for the area of the big of QRST, making it the subject of formula is now 16 over 25 of area of triangle PRQ. And we know that area of PRQ is half base, which is 5, times height, which is 12. So this is 6 times 16 is 96 over 5, which is 1 carry 46 is 9, remainder 1 over 5 cm squared. So that's the answer. Okay, what is the area of triangle QST? This one. So let's start by locating, let's call the height here, let's call it H1. Let's call this one H2. And let's call the common side here to be A. Okay, so want to get what is the area of QST? Well, we know that area of the big triangle, so let's call it, okay, let's use so that it will be easy. Let's call it A1, A2, A3. Okay, let's call this A1 Let the area of this A1, this is A2, and this is A3. So we know that, as you can see, the ratio that these two triangles, this PQR and the big one, are similar. So we see that triangle PST is similar to triangle PQR, yes, which implies that the ratio of their areas must be proportional. So we have, if we use A1, this A1 plus A2 plus A3 over A1, so the ratio of this one to this small one is the same as the ratio of their corresponding sides, yes, and the corresponding sides are the heights. So for the big one is H1 plus H2. The ratio of the squares, sorry, forgot the squared, A1 all squared. So that's it. So you can see that this over this is 1 plus A2 over A1 plus A3 over A1 equal to, this is 1 plus H2 over H1 all squared. Okay, we are not giving A2, we are giving A1. So, but if you see, but from here we can easily, if I do A3, the ratio of A3 to that of A1, area of A3 is half, the base is A, while the height is H2, over half, the base is the same as A, is the same A times H1. So what do you have to say? You can see that A3 over A1 will be H2 over H1. So what am I trying to say? I will replace these two. I will replace H2 over H1 with A3 over A1. Yes. So we are continuing. So we'll substitute the values. A2 is that what we are looking for. A subscript 2, y A1 is 8 plus A3 is 12. A1 is 8 equals 1 plus A3 is 12, that's 12 over 8 all squared. So this is 1 plus so we'll see that this A2 over 8, you know, this is 1 plus 12 over 8. Yes, 12 over 8 is 3 over 2. 1 plus 3 over 2. Why the same thing? 1 plus 3 over 2. So I can factor that 1 plus 3 over 2, which is 1 plus 3 over 2 is 5 over 2. So what is common is 5 over 2. Do you get? I'm factoring. This is now 5 over 2 all squared minus 5 over 2. So we're left with 5 over 2 bracket 5 over 2 minus 1. Do you get the logic? This is 1 plus 3 over 2. 1 plus 3 over 2 is 5 over 2. So if I move it to the other side, it's now minus 5 over 2. But this one is also 5 over 2 all squared. So I factored 5 over 2. So making it this A2 over 8 equals 5 over 2 times, that should be 5 minus 2 is 3, so 3 over 2. So this is a2 over 8 times 15 over 4. So we'll have that a2 is now this 15 times 2 is 30. So that's our answer. It is 30 squared, 30 cm squared. What's the area of USRQ? Okay, this is a quadrilateral, but I'm seeing two triangles there, so I'll use ratio of areas of similar triangles, two similar triangles. So if I do area of triangle PQR to that of triangle PUS, see that the ratio of the corresponding side is 6 over 2 root 2 all squared. Now the ratio of areas of similar triangle equals the ratio of the squares of the corresponding side. This is 9 over 2. Okay, but we're asked USRQ, so I need to bring in USR. So I'll do area of the big one, which is PQR. PQR is the small one, which is PUS, plus the quadrilateral USR. UXRQ. So I've brought in that PUS. This is 9 over 2. And this is 1. This divides this is 1. Why this does? This is 1 plus this over this, so which implies that area of UXRQ to that of PUS will now be 9 over 2 minus 1. You get this over this is 1 plus that. So that one crosses 9 over 2 minus 1 is now 7 over 2. Okay. So we're looking for, so if we make what we are looking for, the subject of form UXRQ is now 7 over 2 of area of PUS. Yes. So we need to get area of PUS because the size of, looking at this, we see that is an isosceles triangle. Yes. It's an isosceles triangle. So we can bring in the height, because the height is a perpendicular bisector. So the height here, yes, the height is a perpendicular bisector. So if this could be partitioned as root 2 and also root 2. So if here is root 2, here is root 5, here should be root 3 by Pythagorean theorem. So we now go back. This is now 7 over 2 times half. The base is 2 root 2. The height is 3 root 3. Therefore, the area we are looking for is now this 2 to root 6, so 7 over 2 root 6 cm squared. So that's option D.